Hi there, algebra friends, and welcome to more about quadratic functions. Specifically, we're going to look at how they look when they are graphed. Now, many of us know there are these parabolas that can open upwards or open downwards, but do we know all these vocab words? First of all, let's go back and review. We've so far have seen this form right now. We've seen it as originally y equals x squared. That was our typical opening upwards parabola. But then when we learn transformations, we learn that we can pick it up and move it, maybe to the left and right using the h. Maybe we can move it up and down using the k. And then also we learn that we can do some kind of vertical stretch or shrink with the a. And also we can learn that the a value, if it's negative, if a value is less than 0, it actually will flip it over the x-axis and make it a downwards parabola. So up here, this one's opening up because the a was positive. But in case the a is negative, down here, it will flip it over and we'll have a downward parabola. And as we saw some examples in real life, this form of the parabola is probably more obvious in nature and in the military, and just anytime we throw something with gravity, we usually get this downward parabola. But we also have what's called the standard form. The standard form here is this, ax squared plus bx plus c. Notice that there's no parentheses that you see underneath it. It's just a's and b's and c. The first term has an x squared, the second one has an x, and the last one is just a constant number c. Okay, well, maybe we'll figure out how this is going to help us later, but I can tell already just by looking at it, he doesn't look like this, so I can't really see transformations very well. But maybe there's a better way that I can analyze the standard form. The other reason why I really like the vertex form is because we learned that the vertex v, the point, which is either over here on the right-hand side, the lowest point here when it's opening upward, or in the purple, the highest point when it's opening downward. That's our vertex. When you're in vertex form, the vertex is right there. It is the h and the k values. So vertex form is great because the vertex is literally right there in front of your face. In standard form, I don't really see the vertex, do you? So we're going to need to find another way to find the vertex when we're in standard form. Okay, we'll figure that out a little bit later, but for now, all right, here's all the important parts that you see of a parabola. Parabola is the shape of the graph of a quadratic function. First of all, one of the neatest things about a parabola is that it is completely symmetric along this vertical line. Meaning you could take that parabola and just fold one part over onto the other. It is symmetric. And so what it has here is what's called this axis of symmetry. Axis is just another word for line. Because it's a vertical line, the equation for this will be x equals, well, some number. X equals 4, x equals 3. Here on this graph, it looks like it's going through, looks like x equals 2 here. So this axis of symmetry would be labeled x equals 2. So our parabola is completely symmetric across that axis of symmetry of x equals 2. Also notice that we do have our vertex, which because this parabola is opening up, that must mean our a value is positive. And if our vertex is down here, that means this is our lowest point in this parabola. When this one opens up, the vertex is the bottom or lowest point, or a lot of times we call it the minimum. So this vertex on a parabola that's opening up is called a minimum. We also have a couple of other important points here. We have the places where it crosses the x-axis, which you can do once or twice, or maybe even not at all, but these are called x-intercepts. We also have, if you remember, we have the place where it crosses the y-axis, which is called the y-intercept. And we won't focus on the y-intercept as much. Really, the most important ones we will look at will be, of course, the vertex, the axis of symmetry, and then a little bit later, the x-intercepts will come in and help us as well. So those are all the important vocab words that we need to know. But like we said, when we are in this form called standard form, how do we find the vertex? Well, do you notice down here that the axis of symmetry always goes through there it is, through the vertex. So do you see that the vertex is going to have the same coordinate as the axis of symmetry? So if my axis of symmetry was x equals 2, then I betcha this vertex is at 2, comma, something. But they should share the same coordinate because they pass through each other. Here on this graph, it looks like it's going through maybe 2, negative 1. But most important to see is that x equals 2 on the axis of symmetry matches the x coordinate of our vertex. Let's use that knowledge and try to figure out some important stuff here. So far we know the standard form is ax squared plus bx plus c. The shape is called a parabola that can open up or down. And the two most important parts are the axis of symmetry and the lowest or highest point called the vertex. And they always cross each other. Here's a really nice example here. We have y equals x squared minus 4x plus 5. And that looks more like standard form. That's ax squared plus bx plus c. So just taking a second here, it looks like my a value in front of the x squared is a 1 right here in front. The b in front of the x is a negative 4. You take the sign with it. And the c all the way end is a plus 5. We might need those numbers later, but I just want to list them for now. Well, I do notice over here that because the a value is positive, the 1 in front of the x squared, it must open up, which means our vertex here is going to be a minimum, or the lowest point. And look over here in our graph, you can see here's our vertex. It is the lowest point. Here's our axis of symmetry, which is the vertical line going straight through it. And then we have other things like y-intercepts. We actually don't have any x-intercepts, if you see. It's not crossing the x-axis. But now, how do we find the vertex and the axis of symmetry? Okay. The first really important formula we have to memorize is this expression right here. If we're playing with y equals standard form, if we take the a, b's, and c's and find this, then you have found the equation for the axis of symmetry. And as we also realize, it's also the x-coordinate of the vertex. So this formula right here in the box is really going to be helpful for us when we're in standard form up here. Remember, when we were in vertex form, we didn't need to worry about this. The vertex was there for us. But here in standard form, this is going to be our magic formula, negative b over 2a. So here's our graph. All right, how do we graph this? Let's see. So I think the first thing to do is to find these two pieces. Let's find the axis of symmetry and let's find the vertex. All right, we already noticed here that the a value is positive. So I know it's going to be opening upwards and I'll have a vertex that's a minimum. Great. All right, what if we did negative b over 2a? You can see that if b was a negative 4, that we saw here, then negative b would make it a positive 4. And we divide that by 2a. A here was 1, so 2 times 1 is just 2. So positive 4 over a positive 2 equals 2. That means the axis of symmetry is at the equation x equals 2. When we draw that on a graph, we usually use a little dashed line you see down here in the actual graph. Not a straight line, just a dashed line, because it's actually not really there, but it does help us graph the rest of it. So it's a useful tool, but it's not physically on a parabola graph. All right, we also notice that the vertex should have the same x-coordinate as the axis of symmetry. So right away, if I found negative b over 2a is 2, I can automatically say, well, I know the vertex is at 2, comma, something. But how? How do we find this y value? When x equals 2, what is y equal to? Well, the best thing to do is let's go all the way back to the original equation here on the top. Let me erase all my marks here so you can see where we're going to play. Go back here to the OG function. Let's plug 2 for x, and we'll see what we get for y. Ready? Here we go. So y should be equal to 2 squared minus 4 times 2 plus 5. Great. And back over here, you see they did that work for us. And when we simplified and did our order of operations, we got y equals 1. Great. So I'll put that right there. My vertex is at 2, 1. And if you see over here on my graph, my x and y axis at 2, 1, there's my vertex. And it's going to open up, so it's going to look something like this, but I want to be a little bit more precise. Let's find out exactly what it does. Okay, axis of symmetry, check. Vertex, check. Next thing to do is to find exactly where it's going, let's plug in a couple of points. What we can do is we can just plug in a couple of points off to one side of the axis. I'll just do the left side. And I'm plugging in some x's. And I'm going to make a little xy chart that you see over here on the right-hand side. Just a couple of x values near the x axis of symmetry. So if my symmetry was at 2, why don't we plug in something close to it like x equals 0 and x equals 1. Let's see what happens. So again, when you plug it in, make sure you always plug it back into your original function, back into your original, and get y. And when you do that, if you plug in 0, that's actually a really nice, easy one, because all the x's go away and you get 5. Okay, so over on my graph here on the left, I'll plug in the point 0, 5 right here. Got it. And let's do one more. Let's plug in x equals 1 into my equation. And when I do that, I should get y equals 2. Great. Let's plug that in also. I should get the point 1, 2. Here it comes. You see it on the graph paper? There it is. Now, what they did here in the chart, I'm not going to do. I don't need to waste my time. Because remember, this parabola and every parabola is symmetric along the axis. So do you believe that if I had a purple point on the left, I should have a corresponding point over here? This point should also have a twin over here. So let's find out where. Okay, so it looks like on this top purple point here, this is 2 away from the axis to the left. So its partner should be 2 from the axis on the right. And I'll put it right here. Did that make sense? It just flipped over the axis of symmetry. And similarly, on the point below it, at 1, 2, if that was 1 step away from the axis of symmetry, its twin should be 1 step away from the other side. Do you notice that they have the same y values? That's what they did back over here in the chart. When I got 0, I got 5. When I got 1, I got 2. Do you see the y values over here? It's the same ones. Why? Because it's symmetric. So do you have to do all this work? No, save some time. Just graph a couple of points on one side and then flip over using symmetry, and it's so much faster. I think we got everything we need. All right, I've got a couple points on one side. They reflected to the other side. Vertex is good. Axis of symmetry good. And that's my final graph. Great job. What we should do is we should label some things here. So I'm going to label my axis of symmetry here, so I'm really good. I'm going to label that this is V is my vertex. And that's all we need to do. That's my final version. The version here on the right-hand side is good, but I think I do really like having the axis of symmetry on there, so I'm going to dash that. I'm going to label that, and then I'm going to label my V as my vertex. Not so bad, right? That's how we graph it. And we'll try another example in just a second. But for now, before we do that, can we just take these three apart? Let's just figure out, can you look by the way it's drawn, what's the axis of symmetry and what's the vertex? Domain and range, we're not going to worry about today. All right, if we look at number 1 here on the left, well, it looks like I could fold that parabola along a vertical line right about here. Do you see that? Yeah, there's my vertical axis of symmetry. It looks like it's going through the part x equals 4. So my axis of symmetry is x equals 4. And remember, the axis of symmetry should have the same vertex x coordinate. So I know my vertex is at 4 comma something. Well, we can actually look at our graph. And on our graph, it's right here. It's a minimum. And it looks like it's at the point 4 comma 3. Great. That's our lowest point. That's our minimum. And our graph is opening up. Oh, I just said minimum. So there you go. Yes, it has a minimum. And the minimum would be at 4 comma 3. Now, because it's opening upwards, it's a minimum. If it opened downwards, open that way, it'd be a maximum. So is it opening downwards? No. So does it have a maximum? No. And you see these parabolas with the arrows on them would go on forever. So there's no maximum point. It would go on forever into infinity. So there's definitely no maximum. Domain and range we skip. All right, if you want to pause the video and try number 2, and then try number 3 on your own, go for it. Again, we can skip domain and range. You don't have to worry about that. but try to figure out where is the axis of symmetry, the vertex, and is it a maximum and minimum? Which is it? All right, good luck. All right, I'm on number 2. So I can see the parabola has this little symmetric part here. I can fold it over along this. Well, I didn't draw that very well, Mr. Brown. So let me try that again. That's a little bit better. All right, that looks like that's at the point -2. So my axis of symmetry is x equals -2, equation of a vertical line, which means, again, the vertex is at -2 comma something. And if I look at the graph, this one's opening downwards. So it's a maximum, and looks like it's at the point -2, -1. All right. Oh, this one's opening down, so there is no minimum. It goes on forever, so it gets lower and lower, so there's no minimum point. Is there a maximum? You betcha. And it's the vertex. And number 2 is done. How'd that go? All right, should we check number 3? Number 3 is pretty cool because I got my axis going right through the middle. Looks like it's right on the y-axis. That is x equals 0. So my axis of symmetry is x equals 0. Vertex would again be at 0 something. And if I look down here, it looks like it's hitting at the point -4. This is opening up. So is it a maximum or minimum? Well, it's going to be the lowest point, so it's a minimum. So 0, -4 is not only the vertex, but it's also the minimum because this parabola opens up. Maximum? No. Goes on forever. Good, folks. Hopefully that went okay. But now let's try to graph these on our own and see how it goes. We're going to go for axis of symmetry and vertex first. And then we can figure out, is that a maximum or a minimum? All right, here we go. Here's our first one. So the first thing I like to do when I get these, especially because it's in the standard form of ax squared plus bx plus c, is off to the side here. I'm just going to write what is a and b and c equal to, so I don't have to hunt them down later. Well, it looks like here the a in front of the x squared is a 2. The b here in front of the x is a 4. And the c all the way at the end with the minus sign is a -3. Great, let's get going. Remember our famous formula to find the axis of symmetry is -b over 2 times the a value. Here, that would be b is 4, so I'll put -4 over 2 times your a value, and a over there was 2. So you get -4 divided by 2 times 2 is 4 also, and negative divided by positive is a negative, so I get -1. Great, so axis of symmetry, here we go. X equals -1. That means my vertex is at -1 comma something. But here I don't have a graph. So what we did last time, if you remember, is we're going to take that x value and we're going to plug it back into the original function and try to solve for y. Should we try to do that? I'll do that up here on this side. When x equals -1, y equals. All right, I have to be really careful when I plug this in, so I'm going to use some parentheses here so that my order of operations is pretty solid. Looks pretty good. Now, by order of operations, I have to do the exponents first. So that's 2 times a positive 1y squared, the -1. -1 times 4 is just a -4. And then -3. All right, 2 times 1, I get 2. -4 minus 3. And that looks like to me 2 minus 7, which is -5. Great, I'll put that over here. That means my vertex is at -1, -5. So if you don't have a graph where you can look at the vertex, you take the x-coordinate that you got from the axis of symmetry, and we plug it back in like we did up here on the top into the original function for y. Just watch your order of operations. Hey here, folks, I saw that a is a positive number, which means is it going to open up or down? Did you guess up? You're right, which means the vertex here is at the maximum or minimum. It's the minimum. So I'm crossing out maximum. My minimum is the vertex, which is -1, -5. Great job. All right. You want to try the next one over here? And I'll catch up with you in just a second. Go ahead and pause the video and check back when you're ready. All right. So same thing. Let's go for the axis of symmetry. But again, like I did over on the left-hand side, let's just go ahead and label A, B, and C so we can see it really easily. Now the a in front of the x squared, there's a negative sign, but not really a number. That means it's -1, if you got that right. The b is the positive 6, and the c is the 4 all the way at the end. So over here in the middle, if I'm looking for the axis of symmetry, our formula negative b over 2a would be negative, well, b is 6, so -6 over 2 times a, 2 times a -1. That's -6 over, see, that's a -2, and that should be a positive 3. Good. So x equals positive 3 is my axis of symmetry. That means my vertex is at 3 comma something. How are we going to find it? You plug it into the original. Good job. When I plug 3 in for x, I get negative. Ooh, watch how I plug this in. You see how I did that? I'm going to do the parentheses and square first, and then PEMDAS says multiply by the negative on the outside afterwards. Ooh, that was tricky. All right, if you do that right, we get a pretty big number here, I think. We get 9, make it negative. I get -9. This is 18 plus 4, so plus 22. I think I got 13. Did you get the same thing? That's a very, very high number. I saw over here again that a value is negative. So that means it opens downward, which means our vertex is the highest point or a maximum. So minimum, nope. It's a maximum, which is 3, 13. And it's a pretty high maximum too. Look how high, 13. Good job. But now we can put that all together and try to graph these by hand. So why don't we try, I'll try B and C with you. Or sorry, I'll try B and D because they're both two different forms that we need to see. And then maybe I'll talk you through C, you can try it on your own. And I'll talk you through E, you can try that on your own too. All right, if you feel pretty comfortable and you want to just do this on your own right now before I do, go ahead and pause the video, give it a try, and just check back here and see how you did. All right, this is in standard form. So let's see, A is 1, B, C. I'm noticing that A is positive, so it's definitely going to open up, which means I'm going to have a minimum. Okay, let's go for the axis of symmetry first. Remember our famous formula, negative b over 2a, which would be -4 over 2 times a, which is 2. I'll just put that for now. I get -2. Good. So x equals -2, so I'll put a little dashed line here at -2. Okay, if I can see my boxes pretty well, it's a vertical line going through -2. And I'll label that like that. Now, that means my vertex is somewhere along that x symmetric line. I just don't know where. Is it up top? Is it up on bottom? So all I know, though, it is at -2 something. So why don't we plug that back into the original, plug in -2, and see what we get for y. All right, if I plug in -2, I get -2 squared plus 4 times -2. Oop, running out of room here, plus 3. And I think if I do it right and I simplify that beautifully, I get y equals -1 because you get 4 minus 8 plus 1. That gives you a -1. All right, making some room here. Good, so my vertex is at -2, -1 right here. And I'll put a little v next to it to show that's my vertex. So again, it's going to open up like this and like this somehow. But again, I want to be a little more specific. So remember we said last time, all we have to do is just pick a couple of values next to the x-axis, and then we'll reflect them over to the other side. Now, easy numbers are like zeros and ones and stuff that are pretty small. So last time I know I did the left side of the axis. This time I'm going to do the right side because that's where 0 and 1 are located. Could you do the left side? Sure, absolutely. You get the same answer. I just figure I'll get some easier x values to plug in if I choose the right side. So I'm saying like if I plug in x equals 0, and then even closer, maybe x equals -1. All right, when I plug in 0 into my original, things cancel beautifully, and I just get 3. All right, I'll put that there. 0, 3. Go right there. That means if that's on the right side, 2 away from the axis, do you see that I have an identical point over here because of the symmetry? Did I have to plug that in? No way! So I've saved some space right there. Okay, let's plug in -1. All right, be careful of all the math. When I plug in -1, checking all my math, I think I get 0. Nice. Okay. That means when I get -1, I get -1, 0 right here. That's 1 away from the axis, so do you see that the partnered point would be over here? Because of symmetry. Again, save some time. I didn't have to plug those in. Isn't that nice? Friends, I think we got everything. We got our axis of symmetry. We got our vertex. We got a good number of points here. And that's what our beautiful parabola looks like. Could be a satellite dish. Could be showing the motion of a swing. Very, very useful in real life examples. And that is graphing a typical standard form parabola. How'd you do? Good for you. Let's try D. The reason why I really like to look at D today is because D is not in standard form anymore. It goes back to vertex form. And remember, vertex form has the h and the k right there. So here's our x minus h plus k. So can you actually see that the vertex is the point +3, +2? Well, that was easy. So the vertex is right there. So I'll go and plug that in right now. +3, +2, there's my vertex right there. Now I'm going to kind of go backwards. If my vertex is there, can you folks figure out where is my axis of symmetry? Remember, the axis always passes through the vertex, right? So if I just draw it, it has to go up and down like this and go through my vertex. Can you see what the equation is? If you set x equals 3, you're right, it has the same value as the vertex x coordinate. All right, well, just knowing my transformations, I notice there's a -a out here, which means this one is going to open downwards. So I should have a maximum. Okay, so I got my vertex, I got my axis of symmetry, and again, we just need to plug in a couple of points. But it's going to be a little bit different here because it's in vertex form, so just be careful when you plug it in. So a couple of points to plug in. How about I do the left side, because again, that's where 0 and 1 and easy numbers are, so I'll plug in there. So I'll plug in, well, how about x equals 0 is nice, and maybe x equals 1, and then I'll reflect it over to the other side. All right, now, when you plug in x equals 0, I'm going to need a little space here. When you plug in x equals 0, you're going to have y equals -2, 0 minus 3 squared plus 2. That's how it looks like when you plug in 0. Now, PEMDAS says we got to do the parentheses first. So -2, 0 minus 3 is, got it. Let's keep going. Exponents next. Don't multiply yet. Exponents. So 2 times +9. And now we can multiply. Good. Now, I did something wrong. Did you catch my mistake? Right around here, I dropped my negative. Mr. Brown, be careful. Which means it should actually be -16. Still a really low number. If I actually got 20, do you understand that over here in the graph, I'd be plugging number way up here? Oh, wait. We said that it opens downwards, so that wouldn't make sense, right? So I used a little bit of common sense to realize that I just made a tiny algebra mistake. All right, now, -16 is way off my graph, so I'm just going to estimate right now. It's going to be somewhere down here. I'm just going to put low. I know it's not very exact science. That's 3 away from the axis, right? So if I go 3 on the other side, I should get a partner point right about over here. Okay, so there it is. Looking good so far. That looks like that's going to open down. But let's try one more point. Let's plug in 1. Okay, I'll do that over here. When I plug in 1, y equals -2, 1 minus 3 squared plus 2. Let's do again, parentheses first, and then square, and then multiply by -2, and then add 2. Okay, should we check our answer? Go and take a second, see if you can figure it, and I'll tell you my final answer too. And I got -6. How did you do? So I got 4 after I squared it, times -2 is -8, plus 2 is -6. If I plug that in, I get 1, -6. He's 2 away from the axis, so I can go 2 away from the axis on the other side. Is there any more points I need to graph? No, I'm good to go. And there's my final graph. And you did it. So between vertex form or up here standard form, they're both about the same. Vertex form is kind of nice because you get the vertex a little bit faster. You don't have to do -b over 2a. So it's a little bit better. When we come back, we're going to figure out, just do some algebra practice. How can you change from one form to the other? and we'll do that next video. Great job today, folks. We'll see you next time.